Yeah, we can hear you. Yeah, it's fine. We can see your screen.
Yeah,
Yes,
thank you so
go
much.
ahead.
Thank you, Chair, for giving me this very good chance for me. Actually, it's first time to join African chapter of MRS activities. It's really my pleasure to be with you today. This is Mohamed Gepreel. I'm a professor of material science and engineering in Egypt, Japan University of Science and Technology. Just to introduce myself because I believe such type of activity is very important to have networking between researcher in African country and other in the worldwide. So I'm a metallurgical engineer originally, and I got my master's degree from Cairo University and then PhD from Nagoya University, and joined Egypt Japan University of Science and Technology in 2010 in the Department of Material Science. Actually, Egypt Japan University of Science and Technology is a newborn university, as you know that, or you may know that it started in 2010. It is a bilateral agreement between the Egypt government and Japan government to make this research-oriented university as a hub for Japanese educational and research system in African country. So we are welcoming all researchers and students to join EJUST for conducting their research. Actually, this is the university is mainly engineering, and recently we have introduced pharmacy and other disciplines. This is my lab, who has been started in 2011. Advanced functional metallic materials. As you can see here, we have many international African students, because EJUST actually nominate many scholarship for master and PhD degrees in EJUST. As I mentioned, that's I welcome to cooperate with all respected colleagues in Africa, and invite the researcher, young researcher, to apply for the scholarships. We have around 50 scholarships every year for master and PhD students. Actually, my lab is working mainly in metals and alloys, with alloy design and microstructure control, but sometimes I cooperate with some colleagues, and I take this chance. Actually, the theme of this seminar is about nanomaterials and nanotechnology. So one of the work is related to the theme. But generally, we are working in titanium alloys, high entropy alloys for high temperature application, aluminum battery, shape memory alloys, phase change material for energy storage, and biomedical titanium alloys, biomedical high entropy alloys, and so on. My lab is has these facilities. About we have the possibility to arc melt alloys under vacuum, and we can process the alloys to in form of sheets or wires on heat treatment in vacuum and so on. We have thermal analysis, mechanical property, metallographic. We have high resolution TEM, laser confocal microscopic RD and FMSM, and so on. The common material testing facilities. I come back to the presentation today. Is one of the topics we worked with some of the colleagues about using lead to secondary lead and recycling it to produce lead nanopowders using electrorefining or electrowinning mechanism, and using it for one of the new topic actually we proposed for gamma radiation sensing. My colleagues, as I mentioned, is specialized in radiation safety security. Dr. Amal and Dr. Ashur is in the electrochemistry and material extraction. Lead is very important, and the market is increasing so much. We can see advanced countries are the main producing countries for the lead, which means it's highly connected to the advancement of the technologies and the production and so on. We can see from 2006 to 2020 that the production of lead in the worldwide has been increased around 50%. Only in 15 years, the production capacity has been increased so much. But actually, not only producing is increasing, but also recycling lead is also one of the key. Because lead recycling is easy. So we can see here comparing the recycling with the primary lead that's extracted from the ores, is also the recycling is also increasing so much, so, which is what we call secondary lead. Unfortunately, yet Africa contribution in this the whole market of producing lead or recovery of the lead is very, very small. So I take this opportunity. So we work in this. As we can see here, Africa compared to Asia, America, and Europe is very small. And the whole, the secondary lead production is much higher than the primary one, which means recycling of the used lead. Except in Australia because of many mines. And I believe actually Africa is also very rich with lead mines, but the production yet is not to the level of their capabilities. So I believe that I make a spark today for the researcher to consider this in our countries. Here again, to comparing the world recycling of the lead, the recycling is increasing, the secondary lead production, as you can see here with the years, and the primary is decreasing and so on. China take the big part of the recycling of lead. And sure, we know that China is taking advantage of many important technologies, especially in batteries. We can see here that recycling battery in China only is increasing that so much. It doubled or tripled in few years. So we have to think about using lead, recycling lead as one of the important industry that we have to strengthen in our continent. Dr. Maza has mentioned about many SDGs, but he didn't mention about the item 12 about the recycling, which, as we all know, about the importance of recycling for the sustainability of our life. Actually, recycling lead can be through two main major techniques: is pyrometallurgy, which is just melting in furnace and using reduction by some gases like CO to have liquid lead and then solidifies, or by hydrometallurgy that we use electrolyte to reduce the lead oxides to have lead sediments and so on. And sometimes, and that's we consider also electrometallurgy, which is hydroelectrometallurgy, that we have to use power supply and current for accelerating and controlling the production, the reduction process. Actually, the reduction process using electrochemistry or electrohydro and extraction of recycling of lead has been published by our colleagues in 2012, 14, 13, and so on. So details are there, but some of the information is not yet reported, which I consider today. So I talked to you about what we did. So the lead acid battery is used everywhere and very high consumption. We use the different ways to recycle lead acid batteries. If you use directly the sludge and make electrolysis, or we use this one by remelting by pyrometallurgy, and the secondary lead slag of the process is which doesn't go directly by pyrometallurgy. So we reuse the lead, and lead oxide has gone to the slag to recycle the lead on it. They make crushing and make electro refining, and then we will have electrolytic lead powder at the end. And this is the setup of so this is the lead and lead oxide mixer, and this is the electrodes, the cathodes that deposits lead powder on it, and then we skim the lead powder after cleaning and so on, and then washing and drying and so on. And drying and washing actually is one of the key that's give us the chance or the idea today to have nanomaterial, nano lead and nano lead oxide. Okay, so this is a mixture of the secondary lead. That's, as you can see by XRD here, is a mixture of lead oxide and lead. Okay, so it is a mixture of them. And by the processing, we optimize. I don't go deep in the optimization process of the recycling. Actually, about the current, we use agitation, temperature, solutions, addition of the electrolyte, and so on. Many has been optimized, but at the end, we can optimize the process. I just want to put this away. Okay, and we can see here that the process is optimized and stabilized. As we can see, the process is stable after some times. So the productivity becomes stable and high efficiency of the process. This is a measure of it. So here also one of the tables that show the parameters, effect of the parameters, the electrolyte temperature, the current density, and stirring rate, and the duration on the efficiency of the process. Actually, the efficiency of the cathodic current is increasing by increasing temperature, as you can see here, which means cost, and also specific energy demand for the production rate of how much we use energy to produce 1 kilogram of lead powder is reduced so much by increasing temperature at this given temperature. But sure, like by changing these parameters, we will have we can have different values and so on. Anyway, the productivity also very good, acceptable to be scaled up for the industrial level to produce lead powder or lead nanopowder. If we compare two techniques, electrorefining and electrowinning. Electrorefining is we dissolve the secondary lead in electrolyte, mainly acid containing, which mainly chlor, or we make directly winning of adding this one in the cell, and it dissolve in the electrolyte and directly deposit on the cathode and so on. Anyway, also we optimize the production of lead nanopowders using these two different techniques. Actually, electrowinning is one-step process, electrorefining two-step process, which means cost. But at the end, the efficiency of the one-step process is less than the two-step process. So this should be optimized. At the end, we will have lead fine powders, as we can see here. This is one of the selected condition effect of the temperature on the lead powder production. We can see here also a irregular shape of lead particles. We can have rods, nanorods, fine powders, chunks, agglomerates, and so on. Anyway, at high magnification by TM, we can see that this type of powder is agglomerates of very fine nanoparticles, as we can see here. So we can, at this magnification, this is 50 nanometers. So we have a range of 6 to 14 nanometer lead particle size in an agglomerates and some shells of other of the material itself. Actually, we investigated this deeply, and we could know that the process itself, we will have such type of nanopowder, but this nanopowder is not pure lead. Sometimes, and it depends on the process of the production, it is lead as core and lead oxide as shell. So the XRD shows to us that it is a mixture of lead oxide with different level of oxidation. So we'll have a combination of oxide core, lead metal core in the particle and the shell, or of different level of lead oxides and so on. And depending on the techniques, we can manipulate this percentage or ratio of lead and lead oxide and so on. And this actually, this point is needs still further deep investigation, and I'm calling my colleagues and researchers to cooperate with me to do such type of research, to go deep and manipulate and control this one. And you are free to do it if you won't like to do it at your site, no problem. Once we have such type of lead oxide mixture and core shell, it take an idea for me that why don't we use it? Because lead oxide has the semiconductor characteristics. Why don't we use it for some physical property measurements like radiation sensing? So we make discs of this type of powder in different sizes to consider the size effect of the disc and measure the electrical conductivity as a function of the conditions, given conditions. We see here that the current is increasing with volt. So it is one of the measure of how to say, the semiconductor nature of the material. If we think also about effect of temperature on the electrical conductivity or electrical resistivity is also changing. And this is also one more thing, changing and increasing. The conductivity is increasing by increasing the temperature, which means another sign of the special nature, physical nature of this lead oxide nanopowders mixture and so on. As we can see here, as a function of temperature, this is high temperature, 60 degrees, and this is room temperature as increasing in this way. If we expose this disk to gamma radiation dose with different values, 1 gray, 0.1, 0.5. Yes.
Please, you have 1 minute to wrap up.
I'm almost finished.
Okay, thank you.
Yeah. Okay, so we can see again that the radiation sensing is this type of disk is radiation can sense the radiation level, and as a function of the volt and so on. So it's very easy to calibrate and detect the level of radiation and so on for radiation of cobalt-16 and so on. And this is how to normalize the current change with the dose and so on. So this means it's easy to calibrate and to make a sensor of such type of lead oxide, lead nanoparticle mixture, and so on. I go to the conclusion that electrorefining, electrowinning of secondary lead is a perfect way to produce lead nanopowder. Actually, we are the first to do this technique, and lead nanoparticle powder show unique electrical conductivity change with temperature as it behaves like semiconducting material. Lead oxide nanopowder mixture is electrically sensitive to gamma radiation and can be used for manufacturing radiation sensors. And thank you so much, arigato, and shukran jazilan. I wish my presentation was simple and understandable for our colleagues, and I wish to cooperate with all of you. And I'm ready to answer any question, please.
Thank you, Professor Mohamed, for your presentation. Is there any question? Is there any question? No question. That means that the topic is very interesting and more understood.
I wish
Thank you, Professor Mohamed, for your presentation.
Thank you so much. It's my pleasure to be with you today.
We have a question. Yeah, Dr. Samuel, you have the floor.
Yes, please.
Yes, sir. From your presentation, we talked about lead, but lead is not good for human health.
Sure, but it is used with billions of tons.
Yes, so
in some industries, yeah, without
yeah.
human contact, sure, lead has a problem, but it
Yes.
is in some industries acceptable as no problem in the case of this.
So because of SDG, can't you run away from using them? Can't you have an alternative to lead?
I don't think it is contradictory with SDGs, but the point is how to make it in the operation or in the application to be safer for human. So this is the condition. But I believe it is no problem about using lead in some industries and some components that doesn't have a direct contact with the human body and so on. And to be safe, and the industry of production to be also safe for the workers and the product and so on. So as far as you can take the measures for the safety of the production and using the products, I think no problem. And that's already approved worldwide. I see. You can see US, China are producing many, or the best, or the highest to produce lead products. So this means it's completely safe.
Exactly. Thank you very much.
Okay, thank you.